Okay, Dobry den. My name is David Hearnden. Today I'm going to be talking to you about building the Google Wave client with the Google Web Toolkit, or GWT. And if there's one thing that you take away from today's presentation, I hope it's that you understand how much the Wave team loves Google Web Toolkit. It's really let us build a first-class application very simply. So I'll be talking about our experience using the Google Web Toolkit and how we found building the Wave client with it from the beginning of when we decided to use the Web Toolkit, what thoughts we were thinking. Then I'll talk about the architecture of the Wave client that GWT has enabled us to use. And most of this talk will be about recent changes in GWT over the last 18 months that have put the icing on the cake. And now I'll be talking about the ways you can build efficient, fast, rich web applications using GWT. That will be most of the talk, and towards the end, I'll talk about some other things we do in the Wave client in order to improve your overall experience. Changes we've made to Google Gears, things we do to increase browser performance, and I'll also talk about the mobile client for running Wave on a mobile device. And finally, I'll talk about how the Wave client approaches testing. In particular, I'll be talking about an automated testing tool called WebDriver. So how many of you have used the Google Wave client? Okay, that's a good number. Many of you haven't, which is also exciting. So I've just got a snapshot here of what it looks like. And you can see it's a paneled environment. By default, there are 4 panels open. In the top left, you can see what we call the nav panel. The nav panel has links to particular waves, searches, folders, lets you organize your waves. In the lower left, we have the contacts panel. There you can see all your contacts. It contains presence information, so as they come online and go offline, you can see that. In the middle, we have the search panel. The search panel is how you find waves. It has your inbox. You can archive, mute, you can manage your waves. Each wave is presented in what we call a digest or a search result. This contains the title of the wave, snippets that you haven't read. It contains last modified date, the number of messages in the wave, a title. And then on the far right, we have the wave panel. The wave panel is where you interact with your waves. You can see who's on it. You can add participants to the wave, add robotic participants, view the history of the wave in playback. You can drag and drop images. You can put in gadgets. You can add attachments. You can add tags. So there's lots of things you can do in the Wave client. It's a rich application, and it was all built using GWT. So before we began the Wave client, there were a number of design principles that were very important that we'd be able to keep in the final product. It had to be fast. It had to be impressive. And most importantly, we wanted to think beyond what browsers could do at that time, which was late 2007. We wanted to think, what would browsers let you do in 2-3 years' time, and how can we build an application that isn't limited by browser technology of the day? Another important point is, in all parts of the client, if we can show you a predictable result of your action, we show it to you straight away. We call this an optimistic UI. So as you edit messages, as you move messages around, as you add people to your waves, we show you the result immediately. We don't wait for acknowledgements from the server. as much as possible, we want you not to wait. So you can open your waves, add messages, edit messages, add people, close it, move on to the next wave, and you're never blocked by waiting for a response from the server. So I'll give a quick demo of what I mean by some of these features. Great. So as I said, it's a paneled environment. And so you can resize these panels, move them around. You can minimize, maximize. You can use these panels in a drop-down state. And all these things they're not native to HTML or to the kind of layout that browsers present. This is all built on top. And one of our favorites, people tend either to love this or hate this. We have our own scroll bar. And again, this is not a native piece of browser technology. We implemented this ourselves. And this is all, one more thing I'd like to demo. If the servers, I'll come back to that wave. But something I can show you, here we go, is you can see the number of messages, the count, it goes up immediately as I'm editing. The titles, you can see they update instantly, because this is all done on the client. We're not waiting for acknowledgements from the server. So from the beginning, what is the Google Web Toolkit, or GWT? It lets you write your web application all in Java. The GWT compiler compiles that to JavaScript and builds a web application for you. So what does that mean? It means you can develop your entire application in Java with all the benefits that you get from engineering in Java. A vast array of tools, editors, debuggers, profilers, optimizers, code generators. There's a lot of rich support for developing in Java. The second big win is that you can share code on the client in JavaScript and on servers running in Java. This is particularly important for Google Wave. As some of you may know, every action you do in a wave is represented as an operation. From each character you type, to messages you add, to people you add to the wave are all operations. And these operations get sent from your client to the wave servers and sent out to other clients. These operations fly around concurrently. As these operations pass each other, they get transformed by something called operational transformation. And it is critical to the correct working of the system that every component transforms things the same way, the clients and the servers. So because we're running the same code, the one Java implementation of these transformations, it's the same code in the client compiled to JavaScript and in the server compiled to Java bytecode. We don't need to worry about maintaining two implementations and rigorous testing to make sure they behave identically. We get this robustness for free. The last point about one of the big benefits of using GWT is something called deferred binding. This abstracts away a lot of the variation that you normally deal with in web applications, from which browser you're running in, what operating system, what locale you're running in, whether or not Gears is in the browser. All this is abstracted away. It's essentially a first-class way of using a strategy pattern. So you interact with just a Java interface, such as the DOM or browser events, and it's the same interface, and different implementations get injected in different environments for different browsers, whether or not Gears is available. But you use the one interface, and GWT automatically figures out which implementation to use in different browsers. So the last point is, although you can write your entire application in Java, you can also write as much as you want in JavaScript. You don't have to yield complete control over to Java. The way you do this is you write JavaScript and you expose it to your Java code through native methods. And this is called the JavaScript Native Interface, or JSNI. If you think you can write code better than the GWT compiler, or if there are particular JavaScript functions that you want to use, or particular objects available in the JavaScript universe, you can access all this and write as much JavaScript as you want. So in late 2007, there was an initial prototype of Google Wave, of the Wave client, smoke and mirrors. But then the decision was made, let's build it for real. So it was a very important decision for, would GWT stand up to building a first-class, rich, real web application? So many members of the Wave team were skeptical. GWT was slightly unproven. There were a number of things that GWT couldn't do at that time. GWT was like a cake without icing. Cake is fantastic, but if you want to serve real cake and pretend like you can present cake, you need icing. And most of this talk will be about the icing that's come in the last 2 years. The main reason we chose to go with GWT was that it allows you to operate in a higher level of abstraction. You're not constantly bogged down in limitations of browsers. You can operate at a higher level, do things the way you want to do them, and GWT does a very good job of abstracting you and hiding the details of working with browsers. And this led to us doing our own scrolling and our own paneled environment. So I'll just give a quick overview of some of the core pieces of the Wave client. And every one of these pieces is something that GWT has enabled. The first one is the Wave client runs its own multitasking environment within the browser. As you all know, JavaScript in a browser is single-threaded, but in a rich client, there's lots of things going on. There's animations, there's user actions, incoming messages from the server, maybe background computational tasks. And for a rich application, you really need some way of scheduling these and prioritizing things. So we have our own scheduler. And just a piece of trivia, in JavaScript, if you use the set timeout or set interval functions to yield control to the browser and then get control back so that you don't lock up the UI, the fastest you can get control back is in about 10 to 15 milliseconds. It's not so quick. Even if you say come back in 0 milliseconds, browsers won't do that. But what the GWT team are working on are some very clever tricks for getting control back into your code in around 5 or 6 milliseconds. So for us, where we have our own scheduler with fine-grained tasks constantly yielding to the browser and control coming back so that the interface remains responsive, going from 15 milliseconds to 5 milliseconds is very important, but we don't have to figure out how to do it. We don't need to think how to do it. The GWT team and the GWT tool, the magic just happens. So the next point, on top of the scheduler, is our communication stack. Our Wave client runs a bidirectional communication channel with our servers. It's a Comet-style communication channel, and the messages we get sent as JSON. The structure of these messages is defined in something called protocol buffers. This is a piece of Google technology that was open sourced earlier this year or late last year. It's very much like an XML schema. It's just a basic specification of structure. What protocol buffers let you do is generate Java interfaces and Java implementations of these messages. So on our Wave client, we take these Java interfaces given to us by the protocol buffers, and we have our own client implementations that are very efficient, and also our own customized server implementations that serialize to JSON. But because these are Java interfaces, it means any code we write that interacts with these messages and does all the communication, this code is run both on the server and on the client, and we know it behaves the same way. On top of these messages and this communication stack, we run waves. These waves run in the browser's memory, and we use some parts of Wave for different things. So we use one part to present a conversation where you interact with messages. We use other parts of Waves to control your user data, what you've read, what you've archived. We use other parts of Waves to control your settings, tags on Waves, spell corrections, attachments. There's lots of things that are running in the Waves that you don't see. But the code that runs here, it's all in Java. They're all little domain models, and they all run on Wave APIs. And we use this same code in the client and server. So everything behaves the same way. Next to these waves, we have our own library of lots and lots of widgets. So GWT is a widget-based environment, and all these little widgets are in their own little packages, and we bundle them and compose them together to construct our whole user interface. And I'll be talking a bit about how you build these little widgets. So from this big Java application, GWT lets us run on Internet Explorer through Chrome Frame, on Safari, on native Chrome, and on Firefox 3. So these are the browsers that Wave supports. We're working on a version of the client that runs acceptably well in IE 7 and 8. It's not there yet. And also on a version that runs on mobile devices. These things run already. Oh, question? That's an excellent question. The quick answer is GWT supports more browsers than this. It's just that on Wave, we don't support more browsers, purely because we don't have the engineering resources yet to fulfill everyone's, like, all the reports that come in of what doesn't work on this browser. We just don't have enough resources to support any more browsers. But I'll talk more about that at the end in questions. So like I said, GWT supports more browsers than this. And the browsers we don't officially support, like Opera, IE7, Android, iPhone, you can still use Wave in these browsers. If you load up Wave, there's a little link that says, we don't support this browser, but you can try it anyway. And on most of these unsupported browsers, things still work. They just don't have all the polish. So now I'll be talking about the pieces of GWT that were missing when we first started building Wave. And these have come in the last 18 months. And these are very important for building real, rich web applications. And we hope that you will benefit from the experience that we had using these in GWT. The particular areas that were not so great for building a large application were just the basics of how UI code was constructed, how you deal with CSS on different browsers, how you use JSON efficiently for processing messages, and how you debug in all these different browser environments. And also, GWT originally operated in a mode where it would take your entire application, compile it all into one big JavaScript file, and that was your application. All your obscure features, all the things that hardly ever get used are in that big file, and everyone had to download it if they wanted to use any part of your application. So first up, there's 7 of these in total. The first issue was writing the UI code itself. This is an example of what it looked like almost 2 years ago. And this is arguably a benefit. This is very familiar to people in Java using other widget toolkits like Swing or SWT or AWT. The way you constructed widgets was constructing panels, constructing widgets, adding them together, and in an imperative style, you build your UI in code. But the downside is it's not immediately clear what this is going to look like in HTML. And it's not immediately, it's not the fastest way to build a UI. So now, GWT has a tool called UI Binder. And the way you build your user interface components is through templates. And these are declarative fragments of HTML, decorated with some extra XML. In particular, you put on attributes that in the generated code reference particular fields so that you can programmatically manipulate them in your widget. So all that code you saw before now looks like this. In particular, because it's pretty much just HTML, this lets our UI designers, who are usually more comfortable in HTML and CSS than in reading Java code, our UI designers can look at this and modify it and play with it and customize our UI very quickly. In addition to these templates, there was an issue of how do we customize CSS for different browsers. CSS is notoriously difficult to have a rich presentation that looks the same and behaves the same on different browsers, because they all implement CSS slightly differently. So at that time, we had one big CSS file, over 4,000 lines. No one understood how it all worked, and it was not manageable to build a large application that way. Now in GWT, there's a tool called Style Injector. And what Style Injector lets you do is, along with your templates for each of your widgets, you write CSS rules just for your widget. And these CSS rules get compiled. They don't get just copied into a CSS resource. The GWT compiler compiles your CSS rules. And this gives many benefits. In particular, it validates that you're using class names correctly, that you haven't misspelled one, or that you don't have a rule that's not doing anything. It also minifies your class names. You can use big, rich, descriptive class names and not have to worry that your CSS has big rules. The class names get replaced with small, minimal names. Style Injector also does some very fancy stuff with images. So, as you know, there's a 2 connection limit in the browser. If you have many little images for your different sprites or different parts of your UI, if your browser is downloading all of these one by one as separate image fetches, then it's going to take a long time before they all come in. Style Injector does 2 pretty cool things. First one is it compiles your images into your CSS. You don't have separate images. And it does this using data URLs. And if I can remember, if you look in the Wave client, if you go to anything that looks like a sprite, you'll see something like this. So first off, you can see in the DOM, all these class names they're very short, but they're meaningless, like DAB, FAB. In the code, these are full, rich, descriptive class names, but CSS Resource and Style Injector have compiled those class names into very small ones to make the rules smaller. And this particular element here, what we'd normally do is have a background image or have it as an image tag, but in the compiled, in the GWT compiled version of this widget, the image itself is here as a data URL. So there's no separate fetch of an image making another round trip to the server. And the last thing CSS resource lets you do that lets you deal with the complexity of different CSS on different browsers is through the deferred binding mechanism, you can write rules that will only appear in particular browsers. For example, this is a rule that will only show up in WebKit and Safari-based browsers. And it just adds a little rule to use WebKit border radius. And this rule, it's not that it shows up on other browsers but doesn't do anything. It gets compiled out on other browsers. The next part where we're having difficulties was we knew that our communication mechanism was going to be running JSON, but the way JSON was processed in GWT at the time was quite inefficient. A whole parallel structure of objects was being created, and it wasn't going to scale for large messages, particularly messages containing entire waves. So what GWT does now is a very fancy piece of magic. There's a special class called JavaScript object. Before I tell you about that, in your web application, there's two universes of objects. All the objects created by your application, which are called Java objects, even though it's in JavaScript, because they're created by your code that was originally in Java, it helps to call them Java objects. It's a closed universe. There are other objects in the browser, like the DOM, browser events, messages coming in from the server, and these exist outside the domain, outside the universe of your application. So there needs to be some way to gain access to these external objects. These are called JavaScript objects. And what you do in the Google Web Toolkit is you write special classes called JavaScript object classes, and these classes let you view these external objects in your Java code. So they let you pull in these external objects into your Java code in a very efficient way. So these JavaScript object, or JSO classes, are essentially full of these native methods. And as you can see here, this is an example of JSNI, the JavaScript native interface. That code that is commented out in Java is JavaScript. And the GWT compiler generates or copies that JavaScript into the implementation of this class. But for JavaScript object classes, it does something even better. It completely compiles out all these methods, and everything is inlined away. So that any object that you access through a JavaScript object class, it's as if you are doing direct property accesses on the JavaScript objects. So everything is very efficient. So this meant that we could use JSON and messages coming in from the server. We can have our Java code inspecting these messages, traversing them without creating any extra objects, and they translate to direct property accesses in JavaScript. The next part was, how are we going to debug? Every browser does things slightly differently, and GWT does a very good job of abstracting out these details, but sometimes you do need to get down into the very fine details of what the browsers are doing. Each browser has its own set of development tools for debugging in the browser, some of which are very sophisticated and we love, but they don't come for every browser. But your application runs on many different browsers. So we used Firebug a lot, but you couldn't use Firebug on IE or Firebug on WebKit. So what can you do? So what you do now in GWT is something called out-of-process hosted mode. And what this is a browser plugin for each different browser that links into a Java virtual machine. And this lets you run your code in Java, but it shows up in a browser as real browser code. It's this magic JavaScript, and you can debug, set breakpoints, change the code. And you saw an example of that this morning, but I'd just like to prove to you that it is real. So here we have the Wave client. It's fully functioning. You can see I can resize, I can type, and this is in Firefox 3. And it's running in a real browser, and there's a full DOM there. It's full of JavaScript. But what it's linked to is Eclipse. And here we are in Eclipse, and you can see, unfortunately the resolution isn't so great, but here is some real Wave code. This particular bit of code handles the key events as you move the green reading frame around in the Wave panel. And what I mean by that is when you have many messages, create another one, you can use the keyboard to move this green frame around. So let's say I had some problem with the tab key. As you can see in the code, the tab key is meant to move the frame to the next blip. I can set a breakpoint here, go into the browser, I hit the tab key. You don't see anything happen because it's hit a breakpoint here in Java code. So here you can inspect variables, you can step through the code, you can even change the code. And if I can go back, let's say I didn't like that tab moved down and I wanted the tab key to move up instead. All I have to do is get a bigger screen, and one that's not run over a network. Here we are. All I have to do is move this. Let's say I want it to, wrong one. Let's say I want the tab key to move backwards instead. So I just change the code with all the rich environment you get in editing Java code and Java debuggers. Save, and I continue. I'm running in a special environment. So I will, and I lost my frame. I think the network's going a bit, here we go. My key bindings are a bit strange. All you have to do is change the code, you refresh the browser, and you can see your changes occur. That's the button I need. So all I have to do is come back, refresh, and the GWT compiler is now building your client with the changes you just made. In the recent versions of GWT, this happens as a hot code replacement, so you don't even need to refresh. And you can see there's a console in your development environment that has all the compilation as it's happening. Ignore these red arrows. And you can see at the bottom, it's building, it's building, it's building. The client is going to come back. And you can see I have everything is functioning again. I can move stuff around. But there's new behavior. The tab key now goes backwards. So you can edit code, run code, see what it does in the browser, and iterate very quickly. And most importantly, you can do this in each different browser. So you get the real interaction of how the browser is going to behave. The next part, as I mentioned, GWT runs in a monolithic context. It takes your entire application as a closed universe. It does this for a few reasons, mainly so that it can do very aggressive optimization. But a side effect initially was that it was one big JavaScript file. This meant that all your code for all your random features would all go in one file. Everyone had to download it. So this graph here, you can see the download size of the Wave client over, this was earlier this year, over a few months. It was just growing and growing and growing and growing. It eventually got over a megabyte before gzip. And we started to get concerned because it's a big download just to get things running. So what GWT came up with is something called run async. In your application, GWT can identify these islands of code, and it identifies these islands by you using these run async points. All run async is, it's a method, you give it a callback, and it calls it. That's all it does. But it's a signal to the GWT compiler that it can cut your application at that point. And using these cut points and dividing your code into these separate modules, it can build separate JavaScript files that get loaded on demand. It's not just JavaScript, it's also your CSS, images, any other resources. All this stuff gets automatically carved up into separate pieces, and GWT does all the work of loading these on demand. All you have to do is choose where to put these run async points. So this is an example here of what the code used to look like for when you clicked on new wave. All it did was run this wave creator, but we put it behind a run async point, which meant that all the code that was used when showing and creating waves, such as the wave panel, playback, attachments, slideshows, tags, participants, all that code was not downloaded until you actually used it. So using this, our initial download size dropped significantly. It went from over a megabyte, approaching 1.5 megabytes, down to around 200 kilobytes after we put in some run async points. Along with getting your initial download size small, it's also very useful to know where all your JavaScript is coming from. GWT has a tool now called the story of your compile, and it looks like this. So this is a recent report run on the Wave client, and you can see in total it's about 2.5 megabytes of code, but in the initial fragment there's only about 800 kilobytes. The rest comes in different points. You can inspect these different points and see where all the code is going. You can see how much JavaScript it is compiling to. For example, the wave panel here is contributing about 85 kilobytes of JavaScript. So you can use all these reports to see why your application is getting big. And using those reports, we were able to identify that our message classes were contributing a lot of code size. They weren't complex, it was just lots and lots of boilerplate code. And using the story of your compile reports, we managed to halve the size of the initial download by optimizing these message classes. I think this is the final issue that we had that GWT now supports. The magic JavaScript object classes, they achieve their magic by allowing the GWT compiler to devirtualize all method calls made on JavaScript objects. What that means is that the compiler needs to know whenever there's a JavaScript object that it is a JavaScript object when you invoke methods on it. Initially that meant JavaScript objects couldn't implement interfaces, and this was not good for our goal of sharing code on the client and server. So there's now a special annotation you can use called single JSO impl. This means that you can identify particular Java interfaces and say they can have a JavaScript object implementation. And the GWT compiler figures out all the magic. You can use interfaces again to have different implementations on the client and server, and you can reuse code on the client and server again by using these interfaces. So in summary, there are some recent changes in GWT that really allow you to build rich first-class web applications, from very quickly designing your components using UI Binder, from efficient processing of CSS and letting you manage the complexity of different CSS on different browsers, using the JavaScript object class to use native JavaScript objects very efficiently, out of process hosted mode for debugging in each different browser natively, run async for carving up your application very easily into separate islands that get downloaded on demand, and story of your compile for identifying where all your JavaScript is going. So there's just two last quick bits of this talk. The first one is talking about other parts of the client and other features of the client that improve the overall user experience. In particular, we made some changes to Google Gears when dealing with images. You can drag images from your desktop right onto Wave, and that's it. They upload. In particular, we create the thumbnails on the client using Google Gears, using the worker pool, and we send those thumbnails to the server first so that everyone else can see them. We have done quite a bit of work in keeping the performance of the Wave client or keeping it performing well. We've got lots more work to do, but a few things we've done. I've mentioned run async for getting the initial download small. We have a mechanism called fast start where we pre-compute some of the queries your client will do on startup, such as querying your inbox and what waves are in it. And along with your initial download of first accessing the client, we supply the answers to those queries so that your client can present the results straight away. I've mentioned the inline images that get compiled into the CSS, which means that your browser doesn't do many fetches for extra resources and extra images. We do a lot of stats collection to measure how particular bits of the client are performing. And we do a technique called server-side script selection. I don't really have time to explain it in detail, but it saves you another round trip. We're counting the round trips, the number of times requests have to go from your client to the server and back, and we're very focused on keeping that to a minimum. Once the client is up and running, I mentioned the optimistic UI, which means that we show you results of what you're doing straight away, so that you get the feel that everything is fast and responsive, even though there's a network there and things have to go to the server and back. We do a lot of prefetching so that when you get a search result, all the waves that are there, as soon as they show up, we get your browser to start fetching those waves so that when you click on them, there's a good chance that the data's already there. We can show it to you straight away. And the last point I'd like to make in particular about using GWT is the GWT widget library is very easy to use. You can build things very quickly, but it's not very efficient. And the GWT team know it's not very efficient. If you're not using any browser events, you can get much better speed by interacting with the DOM and constructing HTML directly using GWT's DOM API. So we recommend you use that where possible. We do have a slightly customized mobile client. I'll just show you a demo. And this is virtually all given to us for free because we use GWT. GWT takes care of generating an appropriate implementation for a mobile device, and we just do a few little things like cutting out the nav panel, not presenting multiple panels at once. And what you see is something like this. This is on the iPhone emulator. You can see you have your search panel. It's the same as on the desktop. It presents all your waves. And you can open up waves and you can read them. The mobile client is not so great for interacting with waves, but it's passable for just reading waves. But again, we haven't committed many resources to building a good mobile client. We have half a developer focused on it. But we get all this already for free just by using GWT. So I'll just finish up by talking about how we approach testing. In particular, a particular pattern called the model view presenter pattern we found very effective at producing code that we can test very well across different browsers. Many of you will be familiar with model view controller, but we recommend you look at model view presenter if you haven't seen it already. It's much better suited for running in browser environments where the view and the control are kind of the same thing. In particular, the model view presenter pattern means we can test a lot of our logic in plain JUnit tests. GWT comes with a testing framework called GWT test case, where it starts up a browser environment based on Mozilla, and it will run your tests. It will compile them into JavaScript, compile your tests and your code into JavaScript, and run it. So it is essentially running your code as authentically as possible to running in a browser. But it's quite slow. It's an order of magnitude slower than just plain JUnit tests. So as much as possible, we recommend you keep all your logic in plain Java classes. And this is what we've tried to do. And we found the model view presenter pattern particularly good at doing this. The last point is about something called WebDriver. This is how we do automatic testing of our client through interacting with the browser, with the real browser. So WebDriver is a testing tool that automates user actions, such as typing, clicking, dragging, interacting with the browser. And you run these interactions against just against URLs, against your web application. And you perform some actions, and then you inspect the DOM and verify that things behaved correctly. Importantly, WebDriver produces these events at the native level, at operating system level events, which means that your code is running in its pure form. Other testing frameworks inject some JavaScript that harnesses your code or uses that JavaScript to simulate events. WebDriver produces the real events. And if I can show you a quick demo. It's this one. So WebDriver is fairly new. It came along roughly when we started doing Google Wave. So we've been there from the beginning. It's taken a while to get it working correctly, but now that it is, it's a very wonderful tool. We're very committed to it. What you should see here any second is this is a VNC session, and you'll see Firefox coming up right now. And you'll see magic stuff happen. Someone's logging in, someone's typing. This is WebDriver running stuff, driving native operating system events. You can see it starts up the Wave client, creates a new wave, types some stuff, replies, adds participants, and all this stuff is fully automated, and it's running against the same code, the same JavaScript that you run in your browsers when you see the Wave client. And we can watch these all day. But so lastly, we recommend you try out WebDriver for automated tests. We recommend that this style of test code is what you follow, where each of your UI components, you write a little helper class that exposes the actions users can do on your components. So your tests read like actions. And then at the end, you verify particular state through inspecting the DOM. So this is an example of a real WebDriver test that we have. You go to the Wave panel, go to an editor, type some text, hit enter, backspace, submit, and verify. So in summary, I talked about the initial decision on the Wave product of whether to use GWT to build the Wave client, and following the decision to use it, the architecture of the client that GWT has enabled us to use. Mostly I talked about recent changes in GWT that really allow you to build real, full, rich web applications. Finally, I talked about a few things we do on the Wave client to improve your experience with attachments and images, changes to Google Gears, and what we're doing on mobile. And finally, I talked about how we approach testing using Model View Presenter and WebDriver for automating interaction testing. So if you've got any more questions, I'll take a few questions now. Office hours is from now till 4:30 over in the office hours area. Please come up and ask any questions you may have. There's a few links here for for the Wave documents, for Google Web Toolkit documents, and WebDriver, and all the Wave documents are available in Russian. So thank you, and questions? I can hear you, but not through the mic.
Test. Okay. Thank you for your presentation. I have a question about Python support. I know about PyJamas, but it's, as I know, open source project invented not by Google, and I don't know, do you support it, or do you have any plans in the future to integrate Python and GWT?
In terms of GWT, it's all Java. I don't think there are any plans to have a version for Python. Fred Sauer from the GWT team, he might know more about future directions of GWT. In terms of Wave, we do have extensions which you can build using Google Gadgets, which you can write in Python. But at the GWT layer, it's all Java.
Thank you.
My question is about free JavaScript libraries that are provided by different vendors. Can these libraries be integrated with Web Toolkit?
Yes. It depends on what these libraries do. You do have to know some things about how GWT, what the compiled JavaScript looks like in GWT in order to know how to integrate it with other JavaScript libraries. We recommend you try and use Java and use GWT as much as possible because GWT does so many aggressive optimizations on your code that the more of it that is written in Java, the more you benefit from these optimizations.
Thank you.
Yep. One more question, and then we'll have to move on to the next session. But more questions, please come and find me or Fred Sauer in the office hours to ask. Last question.
Thanks. If I understood you correctly, GWT applications may be run both in as desktop or JavaScript. And you've shown some piece of XML. So this also will be compiled to the desktop.
What do you mean by desktop?
For example, Swing application.
Right.
So with GWT, you may write desktop applications in web style. Is this correct?
I'm not aware that GWT can produce desktop applications. It just produces the JavaScript for a web application, but you can write it in a style very much like how you would write a desktop application.
Okay, yeah. Thanks.
Yep. Okay, thank you for coming. Again, office hours is right now. I hope you enjoy the rest of Developer Day, and I hope you start to use GWT and learn to love it as much as we do.